your notes pulled up for section 2.4. On the first page, it's just a reminder. I think it's a reminder. I think you learned how to do this in Algebra 2. Synthetic division and long division. For most of you, synthetic division is going to be your favorite, but we need to go over both because you can't always use synthetic division when you're dividing polynomials. All right, so the first problem in your notes tells you use synthetic division to find the quotient when you take this 5th degree polynomial and you divide it by a 1 degree polynomial. Okay, so some things that I want to point out to you here, just in the question itself. I want to make sure you're comfortable with some vocabulary. We're going to divide by this. This might be a factor of this polynomial. I'm not sure. How good are you all at factoring 5th degree polynomials? I'm going to guess not very good at all. But I think this might be a factor. Let's check it out and see, okay? So this is a possible factor. If this is a factor, -3 would be a 0, a root, a solution, an x-intercept. That should make sense to you. Also, I want to point out this because it's x to the first. This is a linear factor, maybe. This expression right here is linear. You're going to hear me use that term several times today, linear. Okay, so synthetic division, here's what I'm going to do. If this is a possible factor, then -3 is a possible 0. So I'm going to go up here to the top left corner and I'm going to write -3, and then we sometimes put a complete box around it, or maybe you just kind of put a little half box around it. That might be a 0. We're going to find out. Now what I'm going to do here is I'm going to go through and I'm going to list all of my coefficients for each x term. So this is a 5th degree polynomial, so my leading coefficient is 1, and then the very next power is x to the 4th, so I use the -2. The very next power is x to the 3rd, so I use the -7. There is no x squared. It's up to you to recognize that there's no x squared and use a placeholder. So if there was an x squared right here, it would have to have a coefficient of 0. And then the next degree here is x to the first, the coefficient is 3, and then the 25. So that's up to you to remember and to do that every single time you do synthetic division if you've got a missing term. So what I've done here, I've set it up. Now here's what I'm going to do. I want to leave an empty row, and then draw a horizontal line. So to get synthetic division started, your leading coefficient drops down below your line, and that spot becomes a 1. Now here's where synthetic division gets started. Now I'm going to take -3 times 1, and I'm going to put it here. And I'm going to add. So this is addition, 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 addition. All right, so I add these two and I get -5. Repeat the process. Multiply, I get +15. Add. Multiply, add. Multiply, add. Multiply, add. Finished. This last number right here, this is your remainder. So I have a remainder of -200. Now when you were in elementary school and you learned how to do long division, you would write your answer and then you would go, remainder -200. Like you would use an R for your remainder. Okay, we are so beyond elementary school, we're not going to do that anymore. So a couple things I want to point out. Since I do have a remainder, -3, the one that I wrote up there in the little box in the corner, it's not a 0. And since -3 is not a 0, that's not a factor. This does not go into this polynomial evenly. It comes out to where there's a remainder. Okay? So that's what the remainder tells me. And then the question said, find the answer. Find the answer that you get when you divide. So here's my answer. I divided a 5th degree polynomial by a 1 degree polynomial, which means my result is going to be a 4 degree polynomial. Ready? Here's how I get its coefficients. It's a 4th degree polynomial. This is the coefficient of my leading term. This goes on my next lowest degree power. This goes on my next lowest power, next lowest power. This is the constant that doesn't have the x to go with it. And then remember how to write your remainder. You always put plus my remainder over what I divided by. Right? I didn't really divide by -3. I know it looks like that in synthetic division, but synthetic division, remember, that's just a little trick. This is the trick. X plus 3 is actually what we divided by. See? It told us, divide by this. So I'm going to take my remainder over what I divided by. That's my final answer. When I divide a 5th degree polynomial by a 1 degree polynomial, I get a 4th degree polynomial. Okay. Next one. Oh, and notice too that I used synthetic division when I had a linear factor and my leading coefficient of my linear factor was 1. So I can do this anytime that I'm dividing by x plus something or x minus something. I can use synthetic division. But if this is like 4x plus 7, no. If this is x squared minus 7, no. Has to be a linear factor, leading coefficient of 1. That's the rule to use synthetic division. So next problem says, all right, now let's take a cubic and divide it by a quadratic. Think about what your answer should look like. So this is what I'm dividing by. Just like I did up there, I'm thinking, this might be a possible factor. Maybe it's just not a linear factor, and that's okay. That's okay. I can still call it a factor if I get a remainder of 0. It's just a quadratic factor. So here I go. I didn't work this out because I think it's important for us to do this together. So I'm going to work this out kind of slowly. Notice I put my placeholder in here. So I put every single term under my division symbol, and I used a placeholder. Now, I'm getting ready to see if this polynomial divides into this polynomial evenly. The first place I start is with the first terms. So I'm only looking at x squared right now and 3x squared. Now when you do division, you usually say, how many times does this go into this? Well, don't ask yourself that question with polynomials. Ask yourself the question, what does this need to be multiplied by? Just the first term. Just the first term. What does this need to be multiplied by to get this? Well, I need a 3, and I need another x. So up above, I'm going to write 3x. I need to multiply this first term by 3x to get 3x cubed. All right, and then just like you do in normal long division, once you put your number up there, now I'm going to multiply. So I'm going to take each of these terms times 3x. I'm going to take this times 3x, this times 3x, and this times 3x, and I'm going to write it below. Here I go. 3x times x, I get 3x cubed plus multiply 6x squared plus 3x. Do you remember what you do? Once you get all that written down, do you remember? Now you subtract. Here's where most people make their mistake. You subtract. everything. You subtract everything that you just wrote on your paper. Everything. Ready? What is this minus this? What is this minus this? Negative. What is this minus this? And bring your next term down. Do it all again. First term only. Ready? Oh, it's gone. There it is. First term only. Look at this. Usually you say, how many times does this go into this? It's going to be easier to ask yourself this question. What do I multiply this first term by to get this? I got the x's taken care of. Now all I need is a negative 6. So up here I'm going to write negative 6. Now multiply. Take this times negative 6, this times negative 6, and this times negative 6, and write it down. You subtract everything. Negative 6 plus, gone. Negative 12 plus, gone. Negative 6 plus, gone. You know what this tells me? There's no remainder. You know what else it tells me? It tells me that x squared plus 2x plus 1, that's what I divided by, right? That is a factor of this cubic. Ooh, look at the answer that we got. Since this factor went in evenly, the answer that I got is also a factor. Now, I'm saying this to try to get you comfortable with vocabulary. Something I want to point out, it isn't factored completely. The problem didn't tell me to factor it completely. The problem just said divide. I'm just like so excited I just can't stop talking about it, okay? I did divide. My answer is this. In fact, let's write our answer. My answer to the problem is 3x minus 6. There we go. Finish with the problem. It said to divide. I did. There's my answer. But just for fun, since this went in evenly, that's a factor. My answer is a factor. Just because they're factors doesn't mean they're factored completely. So think about the number 100. Give me a couple of factors of 100. Maybe like 50 and 2. Ooh, yeah, 50 is a factor, but you can keep going there. Same here. This is a factor. We could keep going, but it doesn't tell me to, so I'm going to stop. I'm going to stop talking about it. Okay, so reminder, when your remainder is 0, what you divided by was a factor. Now, this is cool. This is really cool. It says use synthetic division. Use synthetic division to like sub in 2 for x. Sub in 2. You can do that using synthetic division. So you take the 2, whatever it told you to sub in. It's not calling it a 0. It's not calling it a factor. It's just saying find f of 2. So you put a 2 up there. You do your synthetic division. Now, this, what I would normally call this a remainder. 6 is my answer when I sub in 2. How do you all normally sub in 2? You all normally sub in 2 like this. This is just a different way to get the same answer. So this tells me 2 things. This tells me 2 is not a 0, it's not a root, it's not a solution, it's not an x-intercept. How do I know that? Because there was a remainder. And then it also tells me that f of 2 equals 6. Okay, moving on to the back. A lot of words up here. It's based, and I've kept my, I'm keeping my colors going. It's talking about how do you know if this is a 0, a root, a solution, an x-intercept? If when you plug it in, you get 0 for y. And if you plug that in and you get 0 for y, this is a factor. Y'all know that. Says again. Example. All right, so I've gotten the example started and then we're going to finish it together. Show that this is a solution to this. So if I'm looking, I put this, what I think might be a 0, I put it right here. I set up my synthetic division. I do my synthetic division, and would you look at that? The remainder is 0, which tells me, yes, -4 is a solution, a root, and x-intercept is 0. And since -4 is a root, x plus 4 is a factor. Okay, now here's what's cool about this problem. We started with a cubic. How good are you at cubics? Probably not very, especially a cubic where you can't pull out an x. So this has an x cubed. They don't all have an x term. Y'all are not going to be good at doing anything with this cubic unless you're given a place to start. You were given a place to start. It said, start here. Okay, so here's what we just did. We kind of just took a cubic, we divided it by a linear. You know what that gives me? That gives me a result that's a quadratic. That is so important. Let me say that one more time. You started with a cubic right there, cubic. You divided it by a linear, degree 1. Your result is a quadratic. So I'm going to take my result. See this result? I'm going to write it as a quadratic. Looks like this. 1x squared minus 4x minus 12. It's a quadratic. How good are you at quadratics? You should be pretty good. Can you factor it? I think you can. Multiplies to make 12, adds to make 4, 6. 6 and 2. And then that one's got to be negative, and that one's got to be positive. Okay, that was cool. Now, go back up to the question. Ready? It said, show that that's a solution. Check, we did that. completely factor it. Okay, let's write all of our factors. Our factors are, the first one we found was x plus 4. And then the other two we found were x minus 6 and x plus 2. Do you see what kind of factors they are? First degree, first degree, first degree. They're all linear factors, and they're prime. Like, you can't factor that. You can't factor any of these individually anymore. These are prime factors. I want you to make a note of that. These are prime factors. They cannot be factored anymore. And each of these factors go into this cubic evenly. You know what else is kind of cool? Remember the quadratic that I got when I did my synthetic division? This quadratic goes into my cubic evenly. The blue is a factor. Is it a prime factor? Is this blue right here a prime factor? No, because I could factor it even more. So this is what when it says factor it completely, factor it till you can't factor anymore. That's what it means. And then it said, now list all the zeros. That's easy. My zeros are x equals negative 4, x equals positive 6, and x equals negative 2. Solution. Come on. Work with me. What's going on? Well, it's not highlighting. Bummer. I tried to highlight these yellow and it's just not working. Those are solutions. Okay, we're going to do kind of the same thing again. Look where we're starting. Here's a cubic. Y'all are not going to be good at cubics. You're just not. If I said, give me all the zeros, you can't, like if you set this equal to 0, I don't see you factoring this. You can't factor out an x from each term. You can't even factor this by grouping. You're not going to be good at factoring this. So we've given you a place to start. Here's where I want you to start. It's a cubic. I'm giving you 2 factors already. First, let's verify. Let's double check to make sure that this is a factor and this is a factor. So what I'm going to do is I'm going to take my factor, turn it into a 0, and send it through synthetic division. So I'm going to take my factor, turn it into a 0, and send it through synthetic division. Here we go. Do this with me. That's what I thought would happen. Now, let's work on this one. Ready? Time out. I want to show you something. Some of you are going to send 2 through your cubic to prove to me that this is a factor. And that's valid. You can send positive 2 through your cubic to prove that this is a factor. Okay, but hang on a minute. Let me take this down to something much more simple. I hope you can see that. I can maximize my screen. I should have written bigger. Think about the factors of 100. I wrote 25 and 4. Would you agree with me that 25 and 4 are both factors of 100? Okay. But each one of those factors can be factored more, right, into prime factors. So my 25 can be split into prime factors, and this can be split into prime factors. So you know what's cool? Yeah, 5 and 2 go into 100. Wait, 5 also goes into 25. So here's what I think about this. Pretend this is our cubic, and you all just sent a number through with synthetic division, and I want you to take it further. I sent this through my cubic. Look what I got. I used synthetic division on a cubic, and look what I got as my answer. I got a quadratic. I could send 2 through synthetic division on my cubic. You know what I'm going to get? Another quadratic. But here's what's cool. You can send your 2 through a quadratic. And guess what your result's going to be? Linear. So let's take this quadratic. (3x squared minus 7x plus 2). Let's take this quadratic and use it with my 2. 3, negative 7, and 2. Here we go. I did synthetic division on a quadratic, and look what I got. I got a linear. So what are my factors? My factors are that one. We already knew that, right? X minus 2. Let's see, how many factors is that? That's 2 factors. It's a cubic. How many more do I need? Just 1. One more linear factor. That came from here. These are my factors. And they're all prime. Like, they cannot be factored anymore. This can't be factored anymore. This can't be factored anymore. This can't be factored anymore. See this quadratic? It's a factor also, but it's not a prime. It's not completely factored. This can be factored even farther. I hope you see that. So these are all factors of the cubic. They're completely factored, and you can just find the zeros. I think it says, yeah, find the zeros from that point on. So my zeros are going to be negative 3, 2, and, oh, can you do this one in your head? Please tell me you can do this one in your head. Negative 3, positive 2. Imagine setting this equal to 0, okay? Add 1, divide by 3. There we go. Okay, and then one more thing. You can certainly double check if you think those are zeros for that cubic up there. You can check it on your graphing calculator. So what I'm going to do, I have my graphing calculator pulled up. I'm going to type this cubic function into my graphing calculator. Already did. I'm going to graph it. Okay. Now, I am going to, I'm going to verify, well, yeah, you can. You can see that it definitely crosses at -3. That's good. That was one of the ones I wrote on my paper. It crosses at 2. That's good. That's one of the ones I wrote on my paper. This crosses somewhere between 0 and +1. I think it's 1/3. Here's how you can check. This is pretty cool. I'm going to do calculate. So I need to push my second button and then go above trace. I'm going to do calculate. Second calc. All right. And I want to calculate a 0, a root, an x-intercept. Hit enter. Now, your cursor should be blinking somewhere. So what you're going to have to do, this is the one I want to check. I'm pretty confident I know what this one is. I'm pretty confident I know what this one is. I think I just want to check. So if I move my cursor to the left or right, you can see where it goes. Now my calculator is asking me, make sure your cursor is just to the left of the 0 that you want to check. So this is the 0 that I want to check. Yep, I'm just a bit to the left, so I'm going to hit enter. Okay. Now it's asking, go to the right just a bit. So I need to arrow until I go to the right just a bit. Not there yet. Oh, that's good. I'm just a little bit to the right. I'm going to hit enter. And then this is so funny. I've given it a left boundary. I've given it a right boundary. And my calculator says, are you ready for me to guess the 0? Well, I'd rather you tell me exactly what the 0 is, not guess, but whatever. Yeah, sure. Take a guess. So hit enter again. And sure enough, in order for y to equal 0 on the x-axis, x has to be 1/3. Okay, so remember to get there, we did second calc on our graphing calculator.